Welcome to The Explainer. Today, we are diving into a truly fascinating area of artificial intelligence called reinforcement learning. Think of this as, well, the hero's journey of AI. We're going to explore exactly how machines learn to make decisions. And they don't do it by being handed a rulebook with all the right answers. No, they learn by experiencing the consequences of their actions out in the real world. So if you've ever wondered how a completely blank slate agent learns to navigate complex environments, you are definitely in the right place. Let's get into it.
So here's the big question. How do machines learn when there is no single right answer? It's kind of wild to think about. Unlike traditional programming where every single step is explicitly coded for them, or even standard machine learning where an AI is spoon-fed millions of labeled examples, reinforcement learning is entirely about learning through consequences. Just imagine a warehouse delivery robot dropped into a brand new facility. It isn't directly told the best action to take every time it moves. Instead, it just has to figure out its environment, learn from the results of its own actions, and slowly build a winning strategy completely from scratch.
All right, Section 1, the rules of the world.
Before we get too far, we need to establish the basic vocabulary of the world our robot operates in, and it really boils down to four foundational ideas. First up, we have the state. This is simply the current situation the agent finds itself in, like our robot's physical location on the warehouse floor. Next is the action, which is a choice the agent can make in that exact moment. Move left, move right, go forward, or stop. Then we have the reward, and this is the feedback showing how good the result of that action was. Maybe the robot gets plus 10 points for successfully moving toward a target, or a penalty of minus 5 points for bumping into a shelf. Ouch. Finally, we have the policy, which is the strategy or the learned decision rule tying the whole shebang together.
Now, I want to emphasize this crucial point. The policy is literally the ultimate brain the robot is trying to build. Through constant trial and error, the agent is writing its own instruction manual. The policy is the overarching strategy that tells the agent, hey, when you're in this specific state, this is the absolute best action to take. Over time, as the robot experiences more states and racks up more rewards and penalties, this policy transforms from being completely random, wild guesses to a highly sophisticated decision-making engine.
Moving right along, Section 2. The core feedback loop.
Let's see how those vocabulary words interact dynamically in real time, because it builds this continuous looping cycle. The agent acts, and the environment pushes back with consequences. Step 1. The agent observes its current state. Step 2. It chooses an action based on its current policy. Step 3. The environment responds by giving the agent a reward, or a penalty, and transitions the agent into a completely new state. And then, the cycle repeats. Observe, choose, receive, over and over and over again. It's this exact continuous feedback loop that allows the learning to actually happen.
Next up, Section 3, playing the long game.
But here's the thing, our robot isn't just looking for quick, immediate wins. The main aim of reinforcement learning is to maximize cumulative reward. This means the agent actually cares about the total reward collected over time, rather than just the immediate payoff from a single step. Why does this matter? Well, an action that gives a small reward right now might actually lead to a massive penalty later. For instance, if our agent is navigating a maze, it needs to learn that taking a longer, safe path to reach the goal is ultimately far better than making a short, risky move that causes a collision penalty. It literally learns to think in terms of long-term value. To put that into perspective, imagine visualizing a massive final cumulative score, like 10,000 points. That big number proves that sequencing actions correctly over time is the real key to winning here. This makes reinforcement learning a totally different beast from simple one-step decision rules. The agent might willingly accept a small cost for several steps, essentially taking a temporary hit to its score if it knows that those steps are setting it up for a massive final reward down the line. It's really cool. Learning is strictly driven by the total return from decisions across time.
This brings us to Section 4, the explorer's dilemma.
This introduces a crucial trade-off and, frankly, the core strategic tension of our robot's journey. Our robot faces a constant choice, the trade-off between exploration and exploitation. Exploration means trying out actions that the agent is less sure about, kind of rolling the dice to learn whether they might lead to better, undiscovered outcomes. Exploitation, on the flip side, means playing it safe by choosing the action that currently seems best based entirely on what the agent has already learned. A good system absolutely must balance both. Think about it. If the robot relies entirely on one known route, exploiting its knowledge, it might never discover a hidden, much faster route that exists right around the corner.
As the saying goes, exploration builds knowledge.
Exploitation uses knowledge. Hit the nail on the head, right? Too much exploration wastes valuable time trying out terrible options. But too much exploitation means you might miss out on discovering significantly better strategies. Nailing this balancing act is absolutely essential to improving long-term rewards. And honestly, it's one of the most central ideas in the entire field of reinforcement learning.
Now for Section 5, Robots in the Real World. Let's zoom out a bit, because the beauty of reinforcement learning is how incredibly flexible it is. It applies far beyond our hypothetical warehouse. In robotics, as we've discussed, agents learn movements to safely navigate past obstacles. But in digital games, an agent improves its strategy by receiving rewards for successful moves, or maximizing its score on a board. Even in business, things like resource control or software recommendation settings use this exact reward-based learning to optimize outcomes. The environment can be a physical space, a digital game, or a complex business process. As long as actions lead to consequences, the framework works perfectly. Okay, let's quickly review these main takeaways. We have an agent interacting with an environment. The agent acts, and the environment responds with a new state. Rewards act as the ultimate guide, pushing the agent to improve. And through that delicate dance of exploring new options and exploiting known ones, the agent's policy, its core decision strategy, becomes better and better over time. It's like a giant puzzle that solves itself through experience.
So, I want to leave you with this final challenge. Think about that warehouse delivery robot one more time. If you were the one designing it, how would you assign the point values? Seriously, how would you carefully balance the rewards and penalties to teach the agent the perfect policy? One that prioritizes getting to the target as fast as possible, but absolutely guarantees it won't crash into the shelves. Getting that balance right is the true art of reinforcement learning. Thanks so much for joining me for this explainer, and I hope it sparks your curiosity to explore even more.